Imagine looking up one night and the stars are gone, not dead, harvested. Everyone wrapped in metal and drained dry, and still not enough. So humanity aimed a straw at a black hole 4 million times the mass of our sun and started drinking. What could go wrong? And what happens to everything you know when it does? Black holes win the energy argument every single time. The best we've got today is nuclear fission at an abysmal 0.08% efficiency. That is absolute crap. We've been almost there on fusion since 1950 and are still chasing it in 2026. Those magnetic confinement reactors barely sustain plasma for a few minutes and only get you 0.7%. A black hole, 40%. That's not an upgrade, that's a whole different ballgame. To put it in perspective, take a 3-pound cat. Mine is named Tom. He contributes absolutely nothing to society, mostly just living his best life on my couch and occasionally leaving surprises on the floor. But physically speaking, Tom contains enough mass energy to power 6.4 million American homes for a year. Tom, just sitting there. Einstein's equation doesn't care about Tom's laziness, and neither does a black hole. Spinning black holes drag space-time around them like a drain. Except this drain has 4 million solar masses pulling everything nearby into a slow, irreversible spiral. Toss an object in at exactly the right angle, and it splits in two. One piece falls in forever. One piece rockets back out, carrying significantly more energy than it had going in. That extra energy comes directly off the black hole's own rotation. You didn't generate power, you pickpocketed something that could wipe off the face of the Earth without noticing. Roger Penrose proved this in 1969. Peer review still holds up perfectly today. The physics works, which is exactly what makes what comes next so uncomfortable. Hey y'all, if you want to get in on the act and see more cosmic chaos, hit that like button and subscribe in a jiff. It helps the lab ramp up. Well, welcome to the 22nd century. Every star in the Milky Way humanity could reach is already Dyson-sphered. Wrapped in collectors, drained to the last photon. Gas giants have been entirely strip-mined for isotopes, and the global power grid is still struggling to keep up. Somehow. Extremely on brand for us. After 80 years of political deadlock, again very familiar energy, the vote finally passes. We relocate Earth. Yeah. We send our planet smack dab in the middle of the galaxy towards Sagittarius A star, the supermassive black hole 26,000 light years from here. Fasten your seatbelts. We use 2 centuries of terrifying gravitational slingshots, moving one generation at a time. 17 generations are born, put down their roots, and die without ever knowing Earth in its original orbit. To them, this dark void is just home. Year 2400, the straw is built. 47 orbital stations, each the size of our moon, surrounded the black hole in a spiffy grid. Every 90 seconds, a mass driver fires an asteroid cluster at a mathematically precise angle into the ergosphere. One piece falls in. One piece flies back out at 30% the speed of light. Collectors catch it mid-flight, generating infinite power and saving our home, killing 2 birds with 1 stone. Here is the scale anchor. 1 station, 1 single day. That is more energy than every power plant humanity ever built produced across the entire 20th century, combined, including the ones that went very badly, which, for the record, didn't exactly flatter the average. The last gas station on Earth closed in 2301. It's a museum now. They sell souvenir pump handles for $400. 5 stars on every review site. Packed every weekend. The straw works. The math works. Everything works flawlessly. Right up until Station 7 runs a routine shot on a Tuesday, and one number comes out slightly wrong. It looks a little fishy. It is off by 0.003 degrees, smaller than the angle your thumbnail covers at an arm's length. Near a 4 million solar mass black hole, that tiny fraction is the margin between Tuesday and the last day of life on Earth. Both asteroid fragments tumble unstably instead of splitting cleanly. All that stored rotational energy is released at once. We get a massive gamma-ray burst chock full of extreme radiation. More energy than the Sun outputs across its entire 10 billion year life collapsed into a single focused beam. It is headed our way, aimed directly at Earth. Alarms trigger across the grid. Earth's artificial magnetosphere violently snaps on. The planetary shield we built for exactly this scenario manages to kick in right on time. It holds for 0.003 seconds, which is technically better than nothing. Here's the part nobody mentions. The straw keeps going. Every 90 seconds, firing on schedule. Because there is no one left to tell it what just happened. Here's what those next few minutes actually look like. The moment the shield shatters, gamma radiation violently ignites the upper atmosphere, and before the first second even finishes, at exactly the 0.8 second mark, extreme ionizing radiation washes over the surface. It completely fractures the DNA in every living organism simultaneously. Nervous systems don't have the time to register pain. Nothing feels anything. One moment everything is vibrantly alive, then it simply isn't. The entire biosphere erased. The insects, the whales, the bacteria, gone. No screaming, just silent, instant ash. Minute 6. The oceans don't boil, they skip boiling entirely. They convert directly to plasma at 50,000 degrees, hotter than the surface of the sun. Every ocean on Earth, right now, all of them. The Atlantic, the Pacific, every drop of water on the planet instantly turning into superheated gas. Month 9. Recoil from the burst nudges Earth's orbit 0.4 degrees inward. Tidal forces begin pulling the black hole-facing hemisphere billions of times harder than the far side. The crust violently fractures. Gravity literally peels the planet like an orange. A beautiful, glowing, catastrophic ribbon of dead rock. To add insult to injury, the molten iron core slowly stretches into a 6,000-mile ribbon of glowing metal, unspooling directly into the accretion disk. The night sky has no stars anymore. We wrapped those up centuries ago, and now there's no Earth either. All our grand monuments, our history, reduced to a floating graveyard of irradiated carbon. But the straw is still there, still drinking, exactly like we designed it. Which brings us to the question nobody asked before we built it. Be honest, you charged your phone at least once today without thinking for a single second about where that electricity came from. Same. Genuinely same. I know what you're thinking. How could we be so foolish? Never tell me the odds on an extinction event. But the engineers who built that straw weren't reckless. They weren't comic book villains. They were the exact same personality type who ended polio, put rovers on Mars, and looked at an impossible problem and said, "We can figure this out." That instinct is worth something. That instinct built everything worth having. But the error bar just changed categories. A bad oil well ruins a coastline. A bad nuclear reactor poisons a region. A bad black hole extraction system ends biology on Earth altogether. Same human, Same confidence, completely different consequences for being slightly wrong. Turns out move fast and break things has exactly one hard limit. Don't break the thing everyone lives on. The shift that happens here isn't about the machine, it's about the species. We are apparently the kind of creature that can look at a risk this colossal, map it, model it, understand it completely, and build toward it anyway. Is that ambition? Is that stupidity? From where I'm sitting, it's starting to look like the exact same thing wearing different clothes. Every major energy bed in history followed this same pattern. Coal, oil, nuclear. The people who built them weren't wrong for trying, they were wrong by one number. And the universe, it turns out, does not grade on a curve. You'd think we'll learn. We shouldn't hold our breath. You wouldn't even have time. Let's look at the Kardashev scale, fast. Type 1 controls a planet, Type 2 controls a star, Type 3 controls a galaxy. Right now, humanity sits at roughly 0.73. Not even a finished Type 1. What we just watched was a Type 3 project. It ended absolutely everything. This brings us to the Fermi paradox. Good news is, the universe is 13.8 billion years old. Hundreds of billions of stars in this galaxy alone. By pure math, we shouldn't be alone out here, so where is everybody? The answer that won't sit right is this. Maybe most civilizations got to the black hole stage. Maybe most of them were off by 0.003 degrees. Maybe the silence out there is an emptiness. Maybe it's what comes after the straw. And here's what should actually bother you. We're not at that stage yet. We're at 0.73, running on oil and arguments, and we already can't agree on what error bar we're comfortable with. We have politicians constantly poking holes in the math while the temperature rises. The Penrose process is real, Sagittarius A is real, and it's spinning right now, 26,000 light years from wherever you're sitting. The only thing we invented today was the targeting error, or we just moved it further down the calendar. Before you go existential, don't forget to hit that like button and subscribe for more deep dives. The universe has laws, but we're here to push them to the breaking point. I'm Rabo, and the lab is always open. Catch you on the next one.